Today we are going to learn how to calculate potential energy. So let's start with a real quick review of potential energies and the different types. So remember that potential energy is energy that is stored and it is waiting to be used later. Some examples of potential energy: we have gravitational potential energy. This is energy due to an object's position. So the higher up an object is from the ground, the greater the potential energy because it has a greater distance that it can travel. We have elastic potential energy, which is energy due to compression or expansion of elastic objects. So the greater you stretch something that is elastic, the greater potential energy you're giving it. The greater you compress an elastic object, the greater the potential energy is. So if we notice in this moving image here, this first ball compresses a whole lot when it hits, and as such it bounces back faster and higher. The last ball barely compresses when it hits, so it barely moves because it did not have a lot of potential energy from compression. We also have chemical potential energy. This is energy that is stored within the chemical bonds of an object, such as coal. Coal has a lot of potential energy. We can burn it to cook our food, so it creates light and heat. Another common one, batteries. Batteries have a lot of stored chemical energy in the chemicals within them. We use that potential energy to convert it into energy that runs our cell phones, our computers, our cars, flashlights, etc. All right, here's our equation for potential energy. So PE equals mgh. Go ahead and add this to your equation sheet. Be sure as you are writing it down that you are including what each letter stands for and the unit that should be provided to go with it. Because remember, your answers always have to have a unit to get full credit. So PE stands for potential energy. It's a type of energy, so its unit will be joules. M, as it always has, stands for mass. We're scientists, so we're going to use kilograms for that mass. G stands for gravity. This is a constant. We've already learned this constant, so it should already be on your sheet there, but go ahead and add it again in this location. Gravity on Earth is always 9.8 meters per second. And then the H stands for height. Height is a measurement of distance. It's the distance from the ground. And so we are scientists. We will measure that in meters. Okay. Now, for those of us using the triangle method, we can still use the triangle method, even though it is a little more complicated because we do have 4 items instead of 3. So since these are all multiplying, m times g times h, they all go on the bottom. And so when you are solving problems using this method, remember you always have to multiply first and then divide. So for example, if you do not know the letter H, you would fill in your other numbers. You would have to do m times g first, then do PE divided by that answer that you got. Okay, which means we've got to be careful with our calculators. If you just type it all straight in, PE divided by m times g, it's going to give you the wrong answer because it doesn't know how to do the math correctly. Okay, so you have to do PE divided by parentheses m times g close parentheses. Okay, if you need help with that, just get into contact with me. I'll be happy to work through some with you so we can make sure that your calculator is getting you the correct answer. All right, let's do an example problem. A baby carriage is sitting at the top of a hill that is 21 meters high. The carriage with the baby weighs 12 newtons. What is its potential energy? So let's analyze this problem and say, what do we know? Okay, 21 meters high, so we have a height. And then I have 12 newtons. Newtons is a force. Okay, what am I looking for? What is its potential energy? Okay, so I need my potential energy equation. PE equals m times g times h. Now I have an h, but I don't have an m or a g. Well, g, that's a constant, so we can go ahead and add that, 9.8 meters per second squared, because that's gravity on Earth. So now I have a g and an h, but I don't have an m. I have an f instead. So I'm going to look at my equation sheet, and I'm going to say, okay, how can I get a mass if I have a force? And so we have our old friend, the force equation. Force equals mass times acceleration due to gravity. Okay, so I can say I need to know my mass. I know F, I have my force. I know acceleration due to gravity, that's a constant, so I can solve. Okay, so m equals F divided by A. Plug in my numbers. My force is 12, my gravity is 9.8, and I now have a mass of 1.22 kilograms. Okay, so I can now put my mass into my known category, and now I have an m, I have a g, I have an h. I can now solve for my potential energy. Okay, so I just plug in my numbers. 1.22 times 9.8 times 21, and I get 251.08. It's an energy, so my unit is joules, and that's my final answer. Okay, so this is the long way of working it out, and it takes a little longer because we've got that extra step in there, but it is good. It is the correct answer. It is how to work it out, but there is a little bit of a shortcut if you understand how the math works. So get ready to have your minds blown. Okay, notice that m times g in our PE equation is equal to m times a in our force equation. So m times a is equal to m times g is equal to force. So when we're given force, we can just use that, okay? So let's look at the math of how that happened. So notice in the last problem, so hopefully you took notes, look down at those notes. You'll see that the first thing we did was we solved for a mass because we didn't have a mass. And to do that, we took the force divided by gravity, and we got the 1.22 kilograms. But then if you notice, the next step we did, when we put it back into that equation for potential energy, we did that mass that we calculated times gravity. So we did the reverse. We just took this number, multiplied it by gravity again. So we just reversed what we did. Okay? So that means that you don't have to do that step. If you are given a force, you can just plug that force in for the m and the g. Okay? You can just plug that right back in because 1.22 times 9.8 equals 11.96, which if you round it is 12. Okay? So you can have this secondary potential energy equation where force times height equals your potential energy. Okay? So that's just a little bit of a shortcut so you can do it in one step instead of two steps. If you don't understand this step and you just want to go ahead and use the two equations, go for it. You're good. You're still going to get answers marked correctly, okay, because they're going to be really close. It's going to be a little bit off in rounding, but you're still going to be close enough that you're going to get your credit because I'm going to know that that's what you did, okay? If you want to do this shortened step but you don't quite understand it, that's cool too. Just get into contact with me. I'll be happy to walk you through some example problems, walk you through that step by step so that you can understand how this math goes. If you understand how to use this equation, that's awesome because they're both the correct way of getting to the correct answer. There's more than one way to get there in this example. Okay? So let me know if you need any help because up next is your independent practice.